But before I do that, I'll explain a few concepts here. So you have you have a microcontroller. You can operate in two configuration from a hardware perspective. You have the sync mode and you have the source mode. Now, what I mean by this, so here's a microcontroller. Here's a microcontroller, and if you wire it in this format here, right? You have the 5-volt signal, and you have a resistor LED, and you're syncing to the port. So if you make this port low, you will have current going in here, and the LED gonna light up. If this port is high, no current gonna flow. In the other scenario, you have a source mode whereby the port has a voltage in it, and you're wiring the LED to ground. So if the port is high, the LED is gonna light up. If the port is low, the LED will not light up, right? So in the sync mode, if the port is high here, the LED will not light up. In the source mode, if the port is high, the LED will light up. All right. Now, one more thing you need to understand. When you talk about the microcontroller, you have ports. If you think about the AVR, so I'm dealing here, I'm going to deal with port D. So you will have, right, you will have registers connected to a port. The first register is the data direction register, right? So in this case, data direction register of port D. You will have the port register, and you will have the pin register. Now, the function of the data direction register is to set the port to either be an output or an input. Okay? And if you so you're gonna set it to be an output, that's a direction. Now, in terms of the port here, you want to say you're gonna write to this port, you're gonna set a value, it's high or low, right? And then the pin register is where if you want to query that port to know the status of the pin, you're going to use the pin register. So you have data direction register, the port register, and the pin register. All right. Now we will get down to the actual microcontroller. Um, so if I look up this here on the Arduino board, you see PD4. That will be we are dealing with port D here, right? So the wiring that I have is from the 5 volts through a resistor, through an LED down to port PD4. So let's get to my wiring here. 5 volts resistor. This is the anode. This is a cathode. The cathode is going in here to pin 4. All right. Now, my C code, because you have an AVR, you have IO.H, you define the frequency of oscillation or the crystal oscillator, which is 16 megahertz, and util that delay will enable you to use the delay function here. So what I have here, I'm setting direction of port D, pin 4, right? PD4 as output. Now, I can try to explain this code here now, right? DDR or of one left shifted PD4. So let's do that now. All right. So if I if I have something like in this case, so data direction register or equal one left shifted PD4. What this really means is that DDRD is equals to DDRD or of one left shifted PD4. One left shifted PD4 is basically if you have from PD0 to PD7, all right? So you're gonna go like 0, 1, 2, 3, 4, 5, 6, 7. So one left shifted PD4 is really you're setting PD4 to 1, right? So, and I'm gonna OR this with the data direction register here. So let us just assume that it's preset at 0, right? So this is my DDR D, and this is my one left shifted PD4. And I'm doing an OR configuration here. So what you'll have here is a 1 and the rest going to be zeros, right? So I'm basically setting PD4 to be a 1, which will be an output. My direction is output. All right? So that explains line 9 in my code, right? So the direction of this port is output. Now let's look at line 12 here, right? I'm saying I'm setting the pin, the port or the pin to low, okay? So if I set it to low, then you will have a current flow, right? And if I set it to high, you'll have no current flow. So let's try to understand the code for line 9, line 12 here. Port D and um, let's get to that. So take all of this out and we get here now. So I have port D and equal to the NOT of 1 PD4. Now, what is this really equal to? So this is the same as saying port D is equals to port D, right? And I don't think I'm making my unsign proper here. And the NOT or the complement of 1 left shifted PD4. So let's try to work this out here. What is this component? Now this here will work out to if you have PD0, PD1, PD2, PD3, PD4, PD5, PD6, PD7. So one left shifted PD4 is going to make pin PD4 1. All right. So let's put a 1 here. And this guy is going to be 0. All right. Now, when we add the toggle to it, we are knotting it, or we are doing a bitwise knot here, right? Each bit, because it's a unary operator, this is going to become 1, 1, 1, 0, 1, 1, 1, 1. So this whole part here reduces to this here. Now port D, let us assume, now port D could be in any state. So we're only concerned if we are concerned about PD4 pin to go to low. So if port D, let us say that port D, its initial state, normally in this case it can be 0. So if I do this, ending here is gonna just be 0. But let me just write it like this. Let me say port D is like 0, 0, 0. So 0, 0, 1, right? 0, 0, 0, 0. Let us assume that port D is in a high state, but I want to set it to a low state. So now when I AND it here with 1, 1, 1, 0, 1, 1, 1, 1. Now, what am I doing? I'm concerned with pin PD4. So PD4 is this guy here, PD4. So whatever is the state of these pins, because I'm ending with ones, I'm not troubling whatever the state, I'll retain it. So if there are 0, they're gonna be retained as 0, right? Because I'm going with ones here. But the bit that I'm concerned with, which is PD4, this is the one that's gonna toggle. So let's say its state here is 1, but when I do this ANDing, it's gonna become 0. So now I have successfully set, right, port D, right? In this case here, in line 12, port D, set the pin 4 to low. I'm not concerned about the other ports, but the demonstration was to say, what if port D was high? How I can set it to low, right? So I'm toggling that, the 4th bit, and making it low. Then I have a delay of 500 milliseconds. And then what I do after that, I have port D, or so let me explain line 14 what's happening here now. So in line 14, so we have a scenario like oops, sorry guys, let me get this going. Port D or equal 1 left shifted PD4. Now what is this doing? So we already know what is whatever is the state of port D. So we have 0, 4, let's say the state of port D is 0, 0, 0. And we are going to OR it with 0, 0, 0, and this is going to be PD4, right? 0, 0, 0, 0. Now when we OR this here, this is PD4. So because this here we left shifted and we have a 1 here and we are ORing, this is going to be 1. So whatever is the state of the other bits here, if they are ones, they will be maintained as 1. But I'm just saying they're 0. So we have a scenario whereby now port D is toggled to a high. PD4. So it's now high. So in line 9, I think, of the code, I had, no, in line 12, I had port B, the pin set to a low. And in line 14 here, I'm setting it to a high. So what I'm saying is, first, you have this 5-volt signal going through here. So if this is set low, there will be a current flow. So the LED is going to light up. And when it's set high, the potential difference is going to be the same. So there will be no current flow. Now, this would be the simple C code that you could write to get this going. Normally in Arduino systems, they have their own code, but I'm just using, I prefer to write codes in C. And now we'll try to simulate the system. So what you would expect here, I'm going for 500 milliseconds. So that's like half a second. I guess in a simulation, I don't know how fast it's going to respond, but the light should go on and off, then on and off. Okay, so let's do that now. So here you go. Light comes on, light goes off. It's actually working pretty fast here. So on, off, on, off. So now let me stop this simulation. Let's change this. It's going too fast. Let's change this here to 1 second. So 1,000 milliseconds and 1,000 milliseconds. All right. And let's start the simulation back. On, off, on, off. Okay, so you can see that you can toggle the light. Now you can write codes here, play with more ports. I can put 2 or 3 LEDs. Maybe I can do a next code for that and show you how you can create more conditions. But this is just a simplistic view of how you can toggle some bits in a register and have a light, going on and off. So I hope you learned something in this video. Um, so please subscribe to my channel Spectrum 1844 for more videos. This is just one of them on embedded systems. I intend to make more videos and look at more, aspects of electronics combined with C and C++ coding. So this is all for now, guys. You have a good day. Bye.